Is AI to machine learning like deep learning is to neural networks? That's a very good question. But before we dive into the details on deep learning and neural networks, I kind of think we should really level set on the real relationship as we start down this hierarchy. So let's get started. Artificial intelligence. Just to summarize with just plainly what it kind of means, we want computers to behave like humans. A grand old stick figure there. All right. So that's what artificial intelligence is really all about there. And we can take it a step further here is with machine learning, we want to provide some data, those ones and zeros, and we would like the machine to have a light bulb here moment of some conclusion that we want it to come to. I feed you data, you understand that data, give me a concept. And through techniques like supervised learning, we always have to kind of tune this data to say, okay, you're getting close. Let me give you another set of data so you can learn, and then I want you to predict the answer that I know I want you to see. This process usually involves you constantly tuning and working with the data. Well, let's take it a step lower when we get into deep learning, which is where we still want to provide the data, just raw data, but instead these are methods that the computer or models, whatever you may say, will come up with their own conclusions, all right? They will go ahead and learn on their own. We just keep providing data, and through different types of techniques, they'll be able to actually uncover relationships. And another question actually came to mind. What are all the concerns about with AI and it learning fast and growing so fast? Well, let's kind of take a look at that particular situation here. Here I have two neurons that you have in the brain. If we're familiar with, let's take you all the way back to high school biology, where we all learned that cells have synapses that communicate with each other, and they fire off synapses, impulses that really allow them to communicate. Well, that's how our brain works. And if you remember from AI, our one artificial intelligence, the one principle that we do have here is to make machines function like humans. Well, that's where neural networks come into play. They actually simulate the way that the brain works by doing a neural network. So I'm simulating this here on how we may have inputs and we'll have outputs, which is the actual result you're looking for. And in between, we can have any number of what we like to call hidden layers. All right. Now, generally in a lot of these, you'll have all the nodes are connected to each other, just like we have in the normal synapses of the brain. They all are aware of each other and can communicate as well. And this can come in various forms depending on the actual context of the problem that you're trying to do. All right. If you wanted to have an output where you just need a probability score, that output may just be one particular node. Or if you have a multiple classification that you need to do, it can be multiple nodes, as you see, as I've envisioned here. And this is just a form of a simple network that you can do. But we'll talk more about now how these are all, you architect these and you resemble these through your SDKs, through programming. You are actually simulating this particular diagram at the bottom here, and you feed it data and data flows through and you get your resulting answer. This is an actual implementation of what a neural network really looks like here. So let's talk about some of the simple neural networks that you can do. So now that you know the foundation of the definition of this, when you want to engage in deploying deep learning through neural networks, you really have to understand what type do I want to do, what's required, all right? So on this side, we'll talk about three different types of simple neural networks that come up very often. The first, the feed-forward network. This is where you have inputs that go to outputs. It goes completely through the actual network there. And through continuously going through, there is a certain feedback where it kind of starts to learn how things works. Next, backpropagation algorithm, BPA. All right. Each layer, each node is going to be connected to each hidden layer, and everyone can communicate with each other here. And by going through and learning, going through the actual data and making decisions, it's going to start to learn which path is correct. And it's going to assign, we could call it weights, to which one was correct. And so as you go through a second iteration, it knows I'm going to keep trying this path, and it'll keep trying different nodes to really get back to where it has a correct decision that it needs to make. The third, convolutional neuron network. This is more on the side where you do a lot of classification type of decisions that you want to make. Let's take, for instance, image processing. All right. One of these neural networks may have more hidden layers. And of course, depending on what you're trying to do, you can assign more input nodes, more hidden layer nodes that you want in there, and more hidden layers. So think about CNN, which would be something like, as I'm processing an image, I may have one hidden layer for the colors, one for the edges, one for different aspects of the photo until I come out to the output of, yes, this probability is that, or whatever classification that I kind of want. So taking that into consideration, you're moving on from machine learning, you get into neural networks, you decide what you're going to deploy for your particular problem. What are some of the common use cases here? And what I actually found, it is more common than you think. Some of our outlined 4 use cases here, which we work with and are very aware of every day. The first is, we'll call this one computer vision. As you said, being able to identify images, text, documentations, that's all it being able to see and identify a particular piece of content here. Very critical here. Now, we've all been at home and we all use certain smart devices to maybe ask different questions, all right? And that's where speech recognition, the ability for you to say words and it to interpret it into the right context. Which leads me to my third use case here, natural language processing. And I think we all are aware where we'll have an actual, a computer being able to understand speech, okay? Being able to interpret, translate to different languages. You ask a question and it understands the right context, all right? That comes through these big neural networks of being able to actually learn through. And we've all done shopping on e-commerce at any given day. And I think you are aware on what this can be: recommendation layers, all right, recommendation engines, all right, based upon the data from you buying, purchasing, and what others have bought. It can offer you recommendations on what you may like, or if you're in your favorite streaming service, all right, you've watched this type of movie, this type of genre, I can give you recommendations on what I think to keep you engaged again from there. So now we learn these popular concepts from artificial intelligence to machine learning to deep learning, which we know a form of that is expressed through neural networks here. So as you pick your next architecture and want to actually get involved, this information you can use to kind of make decisions on how you want to gain insights from deep learning.